I'd like to offer a warm welcome to you all, and hopefully you've managed to complete week 1 and 2, but don't worry too much because we have got very clear instructions and tasks this week. This week we're going to look at equations and parabolas, along with some circles and some inequalities. And I just wanted to mention that the resources for all the weeks are available on the Complete Maths website. All the course materials, including how-to guides and tasks, as well as the additional autograph files, are available on the Complete Maths website. You'll see that we have week 1, week 2, and week 3 already available on the website. The files released soon are now available to you all, and hopefully you can work through those. You'll also see the screen recordings for session 1 and 2 are currently on YouTube, as well as this additional session 2 bonus content that Doug and I recorded after last week. Douglas Butler and I are your co-hosts for today, and I'd like to offer my thanks to Douglas for the 3 sessions, and hopefully the 4th next week going to be on data. Doug, if I'd like to hand over to you, and you can introduce week 3.
All right, well, good morning to everybody. Obviously, this week is a bit different from last because you're back at school. So I'm very pleased that you managed to spare some time to come and listen to this webinar. Hopefully, you've all got autograph loaded up and running and in the standard level. This is standard down here. When it opens up with the welcome screen, which looks a bit A-level-y, but I can assure you that there's plenty to discuss and enjoy for the 11 to 16 regions. Now, the statistics is what we're talking about next week. So here we go. One thing you might want to do, just to be sure, is to have a look at view preferences to make sure that it's doing all the things you want it to do. It's the same with just for any program, really. In particular, you can switch from advanced to standard. And you can also choose how you want inequalities to shade, and we'll come across that later on. So I'm going to start off with the first task, and I'm going to be following down the how-to documents here. And we're starting off with something really quite simple, not that one, it's number 1 we want to do. Just plotting y equals x squared minus 4, so standard parabola, pulled down by 4. So the autograph way, of course, is always to visualize before you press OK. So with a blank page, and this is the 2D page, that's the stats page, that's the 3D page. What's missing from here is the complex numbers page, which is in the A-level, the advanced. But for a new 2D page, here we go, and right-click, enter equation. Everything's done through the right-click. So here we have, I'm just going to put y equals x for x squared minus 4. I'm quite a fan of putting spaces all over the place. They're not essential, but and this is an interpretation of it using nice looking mathematics. So we click OK, and I think that's making a terrible mistake, really. You should always, if possible, have the slow plot on, because there's so much to talk about before it actually plots. And that's replot, and you can stop and ask questions, where's it going to come from? Well, x squared looks like that, and then minus 4 is just dragged down by 4. So that's the approach. Now for solving parabolas, we have various tools down here. This is the point mode. This is putting points on integer values. Because we're in the standard level, you can always change it to 0.1 if you want to. But if you pull this out, there's also an intersection mode. And that is looking for intersections. In particular, for example, you see when the cross changes to a little circle, there we have one, and there we have one, and there we have one. So that's your first task, is to draw y equals x squared minus 4 and find those 3 intersection points. And when you found them, if you select one of the points, you can go to the text box, which is up here, and we'll have some words here which are relevant to what it is and the actual answer. And that becomes something you can put up here, and there's a little pull-out arrow if you want to. And you can do the same for all three.
So a nice and easy start to the day. We're a new 2D graph page. We're plotting the equation y equals x squared minus 4. Using the intersection mode, finding the intersections with the x-axis and the y-axis, and then we're using the text box to just display the labels. Hopefully, if you've done week 1 and 2, you'll find that fairly straightforward. And Doug, if you just want to demonstrate how slow plot works again, using the slow plot icon in the toolbar.
You can turn the slow plot on up here. It is on already, but I can turn it off now and on, or you can put it on and off here. But it's very, very important, I think, to do that. And it then creeps along, and you can pause it either by pressing that or the space bar. Lots to talk about: where it's going to go, where it's going to cut the y-axis, where it's going to cut the x-axis, and so on.
And if you just go back to your intersection text box, Doug, can you just select it using select mode? You
can either do a text box this way, there it is, or it's up here, a little picture of A and some text. The thing about the text box, if nothing is selected, the text box enables you to write some messages. You may want to do that, and you can put that anywhere you like.
And then to delete that, Doug, just use the select arrow and click the hello text box, and then just press the delete key.
Time, I think, to show the view on-screen keyboard, because I think it's very important if you're using this on a big screen in front of a class that you're not doing anything which I'm not sure what you've actually done. I'm going to select that, and I'm going to press the delete key, and it's quite obvious what I've done, rather than just doing it secretly with my hands.
And if you can just put on another text box from the other intersection, Doug, and show how the arrow can be dragged to...
You can. There it is. This would be 2, 0. Click OK. Put it where you like. It's attached to the point. It doesn't have to be. You can bring it away, but otherwise, just pull that arrow out there.
And if you double-click that text box, Doug, you'll notice that one of the options is anchor to the point, and you can change the distance as well. So you could change the distance, or you can change the anchor, and then you can move the text box wherever you like on the screen. Hopefully that's taught you something else about text box. I think that's a fairly straightforward first example, Doug. So let's scroll down and see where we get to next.
Okay, now the next one is to make it clear. Let's just have another file. And here we've got the idea that if you've got several points that represent a solution, then they come up as a single object. So I'm just going to get rid of that. Now, if you select the object, the graph, and right-click, go to point, solve, f of x equals 0, that will find both of these. And there could be, if it's a trig function with lots of answers, you're going to get a multiple object. So solve that. And what you notice here is that they are one object rather than two separate ones. Click on that, and the text box will give you a joint summary of what you've got there.
So to build that from scratch, Doug, let's have a new 2D page. Enter the equation, y equals x squared minus 3x minus 2. Click OK. We can fast forward the slow plot and select the line, right click, and in point mode, solve f of x equals 0. That will give us the intersections with the x-axis. You'll notice that we can then select that and click the text box icon. That will launch and give us the equation solver solutions. We can then move that to the center of the graph. If we use the intersection mode now, we can create the y-intercept. And we might want to use grab mode to scroll up a little bit, just so we can see the turning point, or we can zoom out. So again, we've got those zoom options on the left-hand toolbar. So zoom out if we want to. Again, we can use intersection mode, or we can select the line and we can create the turning point using the right-click option. So we select the graph, right-click, point, and the turning point will get labeled.
Because with a parabola, there's only one turning point.
Of course.
So it's probably better to use this one, because this is really useful when there's lots of them. But there it is.
And again, if we add the text box, it will come up with the turning point and the coordinates X and Y.
It's important to realize that these things are not points in the usual sense, because they're a collection of points. So if, for example, if you want to put an axis of symmetry down here, a vertical line, you need to add a point to it. So let's go back to point mode. And this is why it's better to do it as a point in the first place, really. But there it is, a point selected, and right click, line, vertical line. What you might want to do is select the line and right click, edit, draw options, and make it dotted.
How did you get it to display the turning points? The question, Doug. Well, if we select the line, so just the graph, Doug.
Oh yeah.
Right click, point, turning point is available on the point menu when we've got the graph selected. Hopefully that answers your question.
But a reminder that this one will find it as well. It finds one there, finds one here, and that'll take you straight to a point. They're in the way. That's what we were doing on this page, wasn't it? Intersection mode, and wait for the little circle. There it goes. Notice how useful it is to have all previous pages up here if you want to go back and explore
them. Linda, no, you can't currently draw two arrows from the equation solver text box, but don't worry about that. You can add another text box to draw the additional arrow if you need to. But Doug, let's move on to the tasks and let's see how we're getting to those. And Mark, thank you for answering that. Yes, it will snap to the turning point, so that's great. So here we have tasks 1 to 3 available to you. All we're going to ask you to do is just practice finding the turning points and labeling some of the intersections. So if we just give you 4 or 5 minutes just to have a go at those tasks. If you've got any questions about intersections or equation solver or turning points, then hopefully we'll be able to answer those. But if you want to have a look at something a bit more complicated, scroll on to the second page and you can see there we've got tasks 4, 5 and 6, which will hopefully keep you challenged. John, how do you get the equation solver? If you select the line and then right click, then you should get solve f of x equals 0. How do you add the vertical line? So you, from your point, you create a point, right click and line and vertical line. Now remember Doug said that when we've got the turning point or the equation solver lines, we need to put an additional point on top if we want to create the vertical line to show the symmetry. So we put the point, right click,
I'm just saying that if there's only one of them, it really is much better to not bother with this version, but just go straight to intersection mode, and then here you have it. Then you can right-click, line, vertical line. You can select that, right-click, edit, draw options to make it dotted.
Chris, don't worry about being late. The worksheets and the tasks, I've just shared the Dropbox link in the chat with you. Hopefully you'll have received an email with the link as well. But they are available on the Complete Maths website as well. So if you want to go to completemaths.com, you'll find all the resources for week 1, 2, and 3 available there. So Doug, let's have a look at some of the tasks, and let's see if we can answer any questions as they go along. So how do you draw an arrow from a text box? Well, when you've got your text box selected, you should see a small circle appear. I think it's yellow, and then you can drag that around with the arrow. Remember, if you want to move the text box further away from the point, double click the text box and you can remove the anchor or increase the distance away. Where's the text box? Well, if you click in the top toolbar, you've got the text box icon there, but I think you can also get a text box from a right click. Third option down there, text box. And again, if you've opened up in advanced mode, remember you can switch back using view, preferences, and drop into standard mode. How did you change the line to be dotted? What Doug did was he selected the object, right-clicked, edit the draw options, and in the option there, you can change the dash style, and there's various styles there, but you can select the dashes. You can also change the color of the line there if you want to. And if Doug wants to demonstrate how to change the thickness as well while we're there, again, you can just increase the thickness of the line and click OK, and there we have a dashy line. And the equation solver, if we select the line, we can then right click and we have solve f of, on the point menu, solve f of x equals 0. How do you do the intersection mode? If you go to the point menu on the left-hand toolbar, you'll see the intersection mode. You select the intersection mode, and then when you hover over where the points intersect, you'll get a little round circle, and you'll be able to click, and it will add the intersection there. And for the turning point, if you've got the quadratic selected, if you use select mode, select the quadratic, right click, point and turning point, and that should be straightforward. So select the graph, right click, point, turning point, and it will put the turning point in for you, and hopefully that helps. But remember, you've got the how-to guide instructions there. It should hopefully explain clearly how to find those menu options. Yes, Jen, task 6 is a nice task, quadratic through 3 points. So if you've plotted the 3 points, you should be able to right click and select the option quadratic through 3 points. So if Doug just quickly creates 3 points, 1, 2, and 3, we're going to select those points, and then in the create option, we've got quadratic 3 points.
You can also do it the other way around, by the way. You can X is a function of Y, or Y is a function of X.
And there it is, our quadratic through 3 points. So hopefully, Jen, that will help you with task 6. Nice to see that you're working through those. How do you display the turning point as a coordinate? Well, if we use the intersection mode to create the intersection at the turning point, and we can then select the text box, and it will display it as a intersection as a coordinate pair. Remember, you can edit the text in the text box as well. So if you double click the text box, we could just remove the word intersection from the beginning. And we can delete that out and just display the coordinates.
Another way to do that is to look at the label. So here is a selected point, and right click, you can edit its label. Now all points have labels, so they don't show them to start with, but this is point C, and its value is 1.5 and that. So you can show the label, and that's another way of saying what's going on. That's very useful in coordinate geometry, of course. So that was select the point and right click, edit label, or hide label, or show label, or whatever.
Task 6, Doug, do you want to just give a quick demonstration of how you did task 6 again?
What we had here was, let's just bring this to here, and it was this file here. So we've basically put in y equals x squared minus 3x minus 1 and y equals 2x minus 1. So it's a straight line and a parabola. So if you want a sort of summary of all the intersections, select the 2 functions and right click, point, solve intersection. And it will give you a single object represented by 2 squares there. And now if you select them, the text box will give you a summary of the 2.
And task 6, Doug, was to plot the 3 points and create the quadratic through 3 points. So if you just create a new page, it wants you to plot the points minus 3, 0, 2, 0, and 0, minus 6.
Minus 3, 6?
0, minus 6.
All right.
So you just need to zoom out a little bit or scroll for the grab.
Okay, remember in the standard level, it's snapping to integer values, which is very convenient, I think. So select those just by doing a marquee select. Always remember to go back to select mode. You can do that, you know, if you're doing something else, you can press the escape key. That's another way of going back. But if you're not in that mode, you won't select anything. So right click, create a quadratic in 3 points. Select it, text box tells you the equation.
Great. Can you change the default font and color in the text box? Well, if you double click the text box, you have the options there to edit the font, and you can also change the style. We can change in there. We can make it bold. We can increase the size. We can edit the frame color, and then we can change the color in there. You can change that to blue if you want, or yellow, or you can even have a gradient fill if you want to play with those settings as well. Hopefully we've given you plenty of time to think about how to use intersection mode and the turning points, and so hopefully we can move on to the
one thing you didn't mention, Rob, was that you could, once you've decided how you'd like your text boxes to be, you set that as the default, and that's how they will be from then onwards. Okay, circles. Again, equal aspect is quite important. Don't necessarily want this down here, so right click, don't show the key, because we're not doing equations now, we're doing circles. Okay, and put a point somewhere. And right click, circle, enter a radius of 3. So what's that going to do? EasyJet go away. Goodness me, how do I do that? I will turn off my, close that. Okay, what's it going to do? There it is. That's a circle of radius 3. We can move this around, of course, and it will change. You can put a point anywhere you like. See, when it changes to a black arrow, it means it's going to put a point on the circle. We probably want that this time, so it's a bit more flexible. If you've got a point on the circle, you can obviously move it all the way around. You can right click, you can do a tangent. You can also select the circle, and the text box will give you its equation. Now that's nice. Remember, the equation of the circle is just a really nice application of Pythagoras' theorem. So where's the center? Ah, well, we can label the center now, can't we? Right click, edit label. Not terribly interested in calling it anything. I just want to know what its value is. So there we are, and let's show it. So when that's -2 and that's +1, how come that's +2 and that's -1? Lots to talk about here. And of course, if you move this, if I move it one to the right, what's it going to do to the equation? Think about it. Let's keep it on the ones. Just watch the equation change and make sure everybody is understanding why the equation ends up the way it does. So that's enough for you to play with. Have a go.
Quick question there, Doug, if you can display your keyboard again.
Certainly can.
And then if we select a new point, create a new point, and right click and create the circle with the center. And this time what we want to do is use the text keyboard there. We want to enter the radius as a third. So can we use √2 maybe? And you'll see there is √2 is available. And then you can just click OK, and then that will create a circle of radius √2. So you can use thirds. You need to possibly enter them using the keyboard if you don't know the keyboard shortcuts. Hopefully that answers your question, Kevin. If
you want to show the radius, go to the line segment mode and just wait for the little white triangle. Now, you see, it doesn't really know where to settle down, so you just want to make sure you're right on the right triangle here, on the point here. And that's the radius, which of course is perpendicular to the tangent.
And we can display the equation of the tangent by selecting the tangent line, Doug.
Certainly can. Wait for the little black arrow to change. There we are. And text box again will give you the equation. Not a
And
very
again,
happy
as we
equation.
move the point round, the equation of the tangent will change, and the equation of the circle will stay the same. A question from Sam there asking, how do we show that it's 90 degrees? Well, remember we showed you how to measure angles in our shape session, but Doug, if you want to put an additional point on the tangent. And
just put a point down here somewhere. Now, the way to do angles, remember, is to select them in such a way that the angle that it draws will complete in a clockwise manner. So that one, and that one, and right-click, create angle in a clockwise sense, 90 degrees, and there it goes. That one, that one, that. Now, if we did this one, this one, this one, we'd be finding this angle here, which would be 270.
It's not possible to currently show the equation of the radius as an equation. It's only a distance at the moment because it's only a line segment, but you could create the line that goes through those points, and I'm sure we could display the equation of the line that goes through those points. So if we create the line through those 2 points, right click and select text box, we can get the straight line that goes through that part of the radius. So you could work out the equation of that radius as well. And remember, as that point moves around, both the equations will change as well. So
you notice it changes from y equals to x equals when the line goes vertical.
And to display the equation of the tangent, we just select the tangent and add the text box. And when we add the text box, it already knows the equation of the tangent. So that will be displayed. Hopefully that answers your question, Mohammed. Someone using what we used in one of the other tests, Doug, where they used the parallel test to display, but they're saying that the right angle square appears on the wrong side for them. But is there a way of them displaying it on the other side?
What, this one? Has it come over here?
Yeah.
Don't know. It shouldn't do. That one, and that one, and right click, create angle. That should work. If you do it the other way around, that one, that one, that one, it'll give you this answer. I'm pretty sure. Create angle. You have to show a reflex, of course. There's 270.
Yeah, if you want to draw a semicircle, we just need 2 points to create the semicircle. That's going to be in the circle option. If we've got those 2 points selected, we can right click.
Now remember, select them in the right order. That one followed by that one will produce a circle, semicircle in a clockwise fashion. Let's just make sure I've done that right. That one and that one should produce a circle down here. Let's have a look. Circle, semicircle, and there it is. If you wanted the other one, it's that one, and right click, circle, semicircle. Now, all these objects, of course, have attributes, and this is where the calculator comes in. Press the calculator, and that will be able to read values of attributes. So, for example, if I hover over this and go click, or does it? Looks like it doesn't. Maybe semicircles haven't
It does, Doug. I think it's just your selection there. So
done something wrong there, haven't I? It's not playing ball today. Don't know about that. Have to think about that. Here I'm clicking on this circle, for example, and it's telling me that I can use the center, X and Y, the radius, the diameter, the circumference, and the area. All those things can be used in calculations.
okay, so let's have a look at the tasks that we've got for that, Doug, and see how we can work through those. I think there's a couple of nice, interesting tasks there with a double tangent for the second or third question. So
we seem to be on to...
We're on 3 at the moment, Doug. You went to circles.
Oh, entirely my fault. Yeah, I can't count. I've always been accused of that.
And Jen, to display the angle, you've got the 3 points selected. You right click, create an angle. But there's the task down the bottom there, Doug. We're looking at number 2, creating the intersection and showing the line equality tests for those two.
So create number 2 to get this situation here. Let's have a look at that. New page. So we want that. Okay. We don't really want any axes now. So one way to do that is to just have no axes. You probably want to be sure about the equal aspect mode. And then right click, circle, radius 3. Let's just do 2 this time, make it a bit smaller. Put a couple of points, wait for the black arrow on the circle itself. Make a couple of radii from here, white triangle to there, to there. Select, deselect, click, right click, line, tangent, deselect, select, right click, line, tangent, deselect, intersection mode, bang, there it goes. Now, if we wanted to check the equality, we put a line segment from here to here, and a line segment from here to here. Select that one, watch it go black. Select this one, watch it go black. No, it's too much. Selected the line instead. If you keep clicking, it goes through the stack when you've got things on top of each other. And to deselect that, to select it again. So now left with this black one and that black one. And right click, line. You can use the parallel test, which is not relevant here, but equality test is nice to show that they're equal.
And to draw the radius again, Doug, if you can just show to use a line segment from the line segment mode, from the point option, you collect with the center of the circle out to the circumference there, yeah, and that will draw the radius in. So.
Of course, moving the center just moves the whole thing around, but that can be moved, of course.
Okay, let's have a look at our next task there, Doug, see what else we've got on the... Matt, if it's displaying the length of the tangent, then you've only got the line segment selected. You need to select the line, and then you should be able to display the tangent.
Number 4 is left to you to puzzle out in your own time, but the alternate segment theorem is one of those ones that is nicely shown by a dynamic diagram.
Doug, why don't you run us through number 5, showing a right-angled triangle inside the circle? You could then animate that to show the angle.
So get rid of those, equal aspect, right click, nothing, point. You can actually draw a circle. That's another way of drawing a circle, is a dynamic circle like this. Go to that mode and you just pull it out, which is even quicker. For this now, we want to put a couple of points. And put a point at the circumference. And lots of line segments. So to measure this angle, we go this one, and this one, and right click, create angle. 60 and a bit degrees. Move these around. And of course, there will come a time when this angle, we ought to be measuring this angle as well. This one, and this one, and right click, circle, sorry, create angle. Let's allow for reflex, definitely. And something quite special happens when this is 180 degrees. You can actually move these points with the arrow keys as well, which is a more controlled way of doing it. And that's 90 degrees, and of course it is always 90 degrees. What happens if it goes the other side? Still 90 degrees.
Okay, Doug, I think we want to spend another couple of minutes looking at those examples. Hopefully people are working through those nicely. If there are any questions, drop them into the chat. Chris, I can see you want to run through the setup of one of those again, but if you can drop in which one you want Doug to run through, that would be really useful for us. Okay, so a quick way to do the line segment. So Doug, if you just draw another circle. So you use the point mode and circle. And then drew the line segments. And question there about the tangents not showing as tangents, Doug. I think we looked at that before. If you create a point and then create your circles using circle, then your tangent won't go through your circle like it is there, Doug. So if you create a new 2D page, create a point, right click and circle radius, and then the tangent point won't go through the circle using that option for circle. That way the tangent can go all the way around the circle without ever going through the circle. So, Justine's asking, how do you do the segment of tangents rather than the whole line to do the equality test? And then we create the line segment that goes between the 2 points. Sorry, Chris, I took Doug off looking at your example there. So if we go back to creating those, we've got the circle now, Chris. We're just going to use line segment mode to put the line segments in that we need. So we've got one from the center, a second one from the center, and then we're going to take a point up to the opposite side on the circumference and then back down again. And then we can measure the angles between them. Hopefully, Chris, that'll answer your question. Phil, angles, so we can quickly run through that. It was in week 1 shape. So if we select the 3 points, and then we have the create and angle option there. Remember, we want to select them in the clockwise direction of the angle going round. And if you want to, you might want to check or uncheck the allow reflex angle. And that will allow, as you move round, the angle to change like that. So Doug's hopes to demonstrate that. And to bisect the line segment, if you select both points of the line segment, so if we select the center point and one of the other points, we can right click, and in the line, we have the perpendicular bisector there. So the other way that you might want to do that is select the 2 points and create the midpoint, and you might just want to create the midpoint rather than the line that passes through as the perpendicular bisector. So select 2 points, and in the point mode, we have the midpoint option. So yeah. Hopefully that answers your question, Jen. Doug, I think it's time we went to task number 2,
Sorry
which
about
is fitting a parabola to an image. So hopefully you're all ready for this one, people. We're going to have a look at fitting a parabola to an image.
First thing you need to do is get the image. So I'll leave Rob to tell you where it is.
Yeah. So if you want to go to a new 2D page, the image has been sent to you. I'm just trying to grab that now. It's the first image we're going to use is the cannonball image. So hopefully you can use that file. I'm just going to select that window, and I just need to resize my window, Doug, just to drag that cannonball image into the chat. If you should already have this image in the files that were sent to you, but there's the fit cannonball. So if you want to take that file, Doug, if you want to just show how you open that file there, if you go to the object and insert image option.
So as long as you can find it, click on it and it will load up.
Okay, so we're using the cannonball image, and then that should be loaded. And then we need to change the transparency so we can see through the image. So
double click on the image. And here's transparency. Around about 30% seems to be reasonable. Now, scale image with axes is something you definitely want to have ticked when you save the object. Otherwise, the object will change its shape. Let's just show you how that works. At the moment, it's scaling object with axes.
Yeah, Doug, the instructions that in the how-to guide say they can just use file and open. So they can just go file and open, and it's
that's good.
file 2A, I think. If you just want to show where that might be in the course materials.
Now, if we're going to try and fit a parabola to this, gravity starts to take a play in it as soon as this poor unfortunate person leaves the cannon. So we want that cannon to be at the origin. So how to do that? Well, this is an object which you can move around either like that or with the arrow keys. You can be quite precise with the arrow keys. And we want to move it so that the gun is just there. Perfect. Look at that. Now I think probably I want to take the hand and just grab the whole thing across. There you go.
We've got some people just struggling to open that file there, Doug. So if you can just show how you can show how to open that. So if you go File, and then Open.
Oh no, it's not that.
We want to do File and Open, Doug.
You do?
Yeah.
Okay.
And then we go to our autograph file, and it was file 3B1 Fit Canon.
Oh, I see what you mean. Yes. I'm in the wrong place. Need to go to desktop.
And it will open the file with the parabola, with the constants ready to be altered. So if you want to insert the image yourself, though, then we go to Object and Insert Image. And that should insert the image, and then you can resize it. To make it transparent, you can double click the image and you can change it. Just in the file to open, if you're going to open the JPEG, then we just do Object, Insert Image. It's not a file open. If you're going to open the autograph file that's already created, then you can browse to 3B1 Fit Canon. Object is in the top toolbar menu. Doug, if you can just show them where the object menu is. It's just there, Object, and Insert Image is the second bottom option there.
The object menu is a duplicate of the right-click menu. It's exactly the same. Sometimes right-click takes you right off the bottom, so it's useful to have that as a double check.
So hopefully we've now all got an image on the screen that is transparent.
Once if your filing system allows, here is just a filer window I've got, and I can just drag it and drop it onto the. That's another way of doing it. So I'd quite like to start this from scratch. So this is what I've done. So I'm going to put the image on. You can make the image bigger once it's on there, just by selecting it and dragging a corner. Double click, transparency about 30%. Okay, we don't want to scale the image with axes immediately in case we want to rescale the axes, although I don't think we do at this stage, but we might. Okay, grab the end of the cannon and take it to the origin, or you can do it with the arrow keys. Hand, drag the thing across here, and now you have some discussion because you've been teaching your students about the parabola and equations of quadratic functions. What's it going to be? It's going to be something of the form, well, it goes through the origin, so it's going to take the form of something like y. Let's just write it down up here. I've got something to write with, which is quite handy. It's going to be something like, it's going to have x as a factor, and then the other factor is going to be the distance from here to there. Now, if we call that b, is it going to be x minus b, x plus b, whatever? Those of you who came to the first session will know that I'm a great fan of minus, because minus represents a positive translation. So that form will take care of most of the situation here, we think. So let's just drag this down again to there. Therefore, that's the equation we want to put in, but you put it in after you've had this sort of discussion. So enter equation y equals ax brackets x minus b. Now, certainly when x equals b, it's going to be where it cuts the x-axis again. It cuts the x-axis at x equals 0 and x equals b. And a, well, a is going to be negative, isn't it? Because when a is positive, you get parabolas this way up. When a is negative, you get parabolas this way up. So it's certainly going to be negative. But if we just click OK with the constants at their default values of 1, what's it going to look like? Well, it's going to go through 0, and it's going to go through 1, and it's going to be the usual way up. Again, lots to talk about before it actually does it. Yay, we've got it right. And now the constant controller comes into its own. Constant controller is up here. By the way, it's not this one. This one is something that's used a great deal on more advanced courses, which we'll certainly cover if you come back for a more advanced course, where you can associate constants to attributes. very, very useful. But for now, just an ordinary constant controller. A needs to be negative, not positive. So we're going to go down. And now let's look at B. B at the moment is 1, but it needs to be about 8.5, I would think. So let's just go up to 8 and now reduce the step so you can climb on. Something that's really hard to do with a slider bar. Okay, and now we're going to take X, so A rather, and reduce A. At the moment it's -1. If we make it -2, that's going the wrong way, so it needs to come up. The next one is going to be 0, which isn't very helpful. So we press this one, which changes the step. So left and right changes the step. And now we come up, reduce the step again. Try this with the slider bar. And that is pretty good. Not absolutely right. I'm going to change B a tiny bit more because it's the center of gravity of this poor unfortunate person who in fact survives this one. But you wonder how many more lives he'll have. Reduce the step and increase it a tiny bit. Just see that it goes through the centers of mass and then reduce A a tiny bit. That is spot on. So gravity is definitely doing its work and it is the shape of a parabola, spot on.
And we can display the text box, which will hopefully display
Yes,
the equation.
That one, and right click, text box. That will show the values of the constants as well.
So there's one there for you to have a go at, fitting the parabola to the cannonball image. I know some of you want to change the transparency, so if you just double click the image and you can edit the transparency further, you can just increase that up to about 50%. It just changes the transparency. But once you're finished, you could remove all the transparency and take it down to 0 again, and hopefully you can see there your nice equation fitted over the top. So plenty of settings for you to play with there. You can obviously change the draw options of the line as well. Drop any comments or questions into the comment box, and we'll give you 3 or 4 minutes to have a go at that one, and then we'll...
You definitely want to press scale image with axes if you're saving the file, so that whatever configuration of the window the user opens it up, it'll all be okay. Otherwise, the image will be scrunched.
A good suggestion there, Pip. You can obviously adjust accordingly to suit your needs for your teaching. So yeah, you could change the equation as well there and make that a bit more complicated. It's just a nice simple example for us to work through. Hopefully that's something we can look at later on.
If you study this at A level with parametric equations, your 2 parameters are the angle of projection and the speed of projection. And to get this chap to hit this very small net, the tolerances were incredible, very, very tight, less than 1% error on either of those parameters, and he's a gone-on.
Good question there from Chris is what's the limit of the parabola model? What does the impact actually happen within the canon? And then people that use y equals ax squared plus bx plus c there from Pip. So yeah, some really interesting conversations can be had around this topic. Hopefully you're just getting used to using the constant controller to edit the values of A and B there. Remember, it's really important to adjust the step using the left and right arrows, and then you can increase and decrease the values with up and down. Okay, for those people that might be getting the error message that the image was created in a newer version, what you want to do is instead of opening the image, you want to open the file 3b2 fit McDonald rather than trying to open the image, or you want to do the object and insert image instead. So well picked up there, Chris. That's why people might be getting that message there, is because you're trying to open the image rather than the file. So Doug, shall we have a look at the next example? So this is what we're going to try and create. It's fitting the parabola to the golden arches. And obviously Doug's created a locus there with a point. And we did look at locus last week when we were looking at functions and inverse functions in particular. So if we start off with inserting the image from the object menu,
Once you've got the object in, double click on it and give it some transparency as before. Now it's going to be the same model as the cannonball one, so we can just do right click, enter equation. And here's the history up here. So we know it's been done before, so we just click on that. And edit constants, well, we'll start off with 1 and 1, which is going to be once again down here and through here and up here. So now we want a new constant controller for this page. And again, we want to make A negative for sure. And we want B. It's going to be around about 3 and a bit, I would think. That'll do. And then back to A again, making it more negative. It's not going to fit perfectly, but maybe just move B along a bit. Okay, what we really want though is only this little bit from here to here. Now B is 3.4, which represents the upper limit of this domain. So what can we do here? If we double click on the equation, click, that gives you the chance to have a look at the startup options. Now we want the startup option not to be automatic, but to go manually, starting at 0 and finishing at B, because we know what B is, it's 3.4. Click OK, and that will make sure that only, let's make it a bit thicker, 4.5, and let's put a golden color. All right, so that's only going to go up from there down to here. So what we want to do now is reflect this line, this curve, in the y-axis. So the way that works with autograph is that you put a point on the parent curve. There it goes. Probably go to 0.1 now. And that point we can transform, right-click transform by whatever transformation we want. So if we want a reflection in the y-axis, there it goes. That produces a point over there, and you can see that as I move this point around, so you do indeed get a reflection. So this is a point that is constrained in some way. This is a point that has a relationship to this point. Therefore, we can create what's called a locus. Sounds complicated, but it's a lovely idea and really, really useful. So for all these possible values, it will create a curve over here. So right-click, just select that one, and right-click, create a locus. Now I noticed that I didn't get the right-click menu that I was expecting because the selection wasn't complete. So just go back to nothing again, just to click that one, and right-click, create locus. Now it's going from there to there, but that doesn't really matter. Just take whatever it's only going to take the values of the other one. Let's just make it a bit bigger. And the color we said wants to be golden. There it is. There we are. We have our two arches.
Hopefully the how-to guide explains the instructions for that quite nicely. You can have a go at creating that one, and then there's one more for you to have a go at. So if we have 5 or 6 minutes for you to have a go at creating a parabola to the golden arches. And if you finish that task, have a look at the basketball example. Remember, any questions or comments can be dropped into the chat, and we can try and answer those as we go through. How do you set the limits for the first half of the parabola is the question there, Doug. So if we click the image, and then we should have the startup options, that we can get to those from a double click, I think, Doug.
You double click on the curve,
yeah,
and then the startup options, we want it to go from automatic to manual.
And the X start is 0, and the X finish is the value for B. and using that constant there allows us to change b, but our startup value will also change as well. So that's really useful there.
So if we make b a little bigger, you see that everything changes.
And Karen, the reflect option, if you've got 1 point selected, is on the right click. It's the bottom option for transform, and then there should be a reflect in y-axis should be one of the options that you've got there. So select the point, transform, reflect in y-axis. When you've then got both points selected, you can then create, under the create option, a locus down the bottom there. For those of you that want to have a play with the animate, you could select the first point and you could probably animate it to bounce along the curve as well. Use the lightning bolt from the top menu and you can change the value there. Automatic repeat from 0 to maybe 3 or something. Like that. How do you cut the graph at the x-axis, Mohammed? Remember, we edited the startup option. Double-click the graph. You get the startup option, and then we can set the x start as 0 and the x finish as b. And Karen, if you're not getting the locus option on create, it's because you need to select both points. You need the original point and the reflection point. Only those two things selected, and then you should be able to select those. And your different values for A and B is possibly because you're viewing the constant controller from a previous page. If you just close the constant controller and open it again, you'll get the constant controller for the page you're working on at the moment. Hopefully you're beginning to get the idea of these fitting parabolas to images. So Doug, maybe if you just run us through how to fix the basketball image, and then we can move on to looking at our inequalities.
Right, the next one is the basketball image. So to notice that if I've got a file ready in a file window, I just have to drag it on and it opens up, which is very useful. So it's pretty similar to what we've just been doing. So I don't think you need to spend time on it now, but that's the solution. Again, a lovely parabola.
And the Okay, Doug, I think it's about time we look at some inequalities. Apologies to those questions we're not answered in the chat. Maybe if you stick around at the end, we'll be able to answer a couple of extra questions for people. I am conscious that we've got another set of tasks for you to have a look at. So we look at this first one. If we just start with a new 2D page and we can create this inequality.
Now, inequalities are determined by the preference set up in view preferences. At the moment, it's set up to shade the reject region. That's my preference because if you've got several of these, it leaves the final area blank. If you don't do that, it's shaded except region, you've got all colliding shadings, and it's not so satisfactory, I don't think. But anyway, the choice is there if you wish it. I've often thought it would be quite nice to have a point that just wanders about and tells you what the value, in this case 2x minus 3y, when is it less than 6? Well, at the moment it's minus 2. So how do we get all this to work? And when it goes the other side, of course, it is more than 6, and this side it's less than 6. So we're shading the reject region. So how do we get this point together? Well, we use the calculator. Now, the calculator can use attributes from anything you click on. So in this particular case, if you click on this, it offers up the x and y. That's all a point's got. The two attributes are its coordinates. Whereas, as we saw in the last one, the semicircle has all sorts of attributes. So we want to have 2 times the x. I'm going to go 2 times. Now, the x value from here is x. I just click twice. Minus 3 times, and click here, y. Now that's simply saying that this point is called A, that's its label. We are not showing its label at the moment. Before text, therefore, it's going to be 2x minus 3y equals space. At the moment it's 1, which is correct. Click OK, and it comes up here. So if I move this one to the right, what's going to happen? It's going to change its x value from 2 to 3. And as it crosses across, it becomes more than 6 and therefore fails the test. It's a dotted line because it's less than 6. If I change it to less than or equal to 6, double click. If I change it to less than or equals, literally you do less than followed by an equal sign, it'll be a solid line. Just hurry it up. Of course, these implicit equations are really wonderful for the slope plot. Where's it going to cross the various axes? So there you go. It's a nice little one for you to try, but we're running quite short of time. But see if you can get the idea of using the calculator to do a calculation on attributes of a selected object. I'm thinking what you could do also is show the label for this object, which will give its coordinates. So click on that, right click, edit label, and all we don't want A, but we want the value, and we want it to show.
And Doug, can you just show how to enter the equation again? 2x minus 3y is less than 6. If you just go equation, enter equation, 2x minus 3y is less than 6. Just check, Jen, that you're using lowercase x and y. It might be that you've got caps lock selected or the shift key down. But if you enter 2x minus 3y is less than 6 and click OK, it should draw the inequality for you. And in the calculation box, if you click OK to that, Doug, and then click the calculator, because we've got 2x minus 3y, he just put 2 times and then selected the x result. And there it is. And then minus 3 times and then the y result. So hopefully that's working for everyone okay. You can enter before and after text if you want to. it's helpful to put in the equation there. But there's no need to have any text. If you just click OK, it'll just display the value as a floating value. So if you show us the tasks there, Doug, I think there's a fairly straightforward introduction there. I think there's some nice tasks there for people to have a go at. Remember, if you want to change the snap setting there so you don't stick to integer values, you can do that by just clicking the 0.1. Or if you want to edit the snap setting further, you can do that in the axes menu, and you can set a custom snap to whatever you want it to be. But yeah, let's have a look at those tasks, Doug, and let's see if we can have a look at those. So the first few are just fairly straightforward. Just create the inequalities, just to get you used to entering the inequalities. And then creating a couple of double inequalities there. It's not till you get to task 5 that it's a bit trickier.
I forgot to mention that if you want this point to be not a little circle but a funny triangle, select the point and right-click, Edit, Draw, Options. And then down here, you've got all the different possible shapes you can have. I want to make it into a diamond, and even bigger still. There it goes. And the 3-1 came from Edit, Label.
And Chris, if you've not got the snap set in there in the toolbar, you can just go to the top menu bar, you go to Axes and snap settings, and you can edit the snap setting there. You can set it to be any value you like.
I've only got a few minutes left, so is it a good idea to just run through the rest of these?
Quick question there, Doug. How do you change the shade region between the accept and reject? I think you showed that from the view preferences. And then in the general setting there, you've got the shade accept region and shade reject region there. Quick question there about the autograph files being shared in advance. We do make them available in the Dropbox, and they are available on the website. We don't want you having everything too early. If Josie, for question 6, if you write it as an improper fraction, 21/4, that will also work for you as well. It does look like we're nearing the end of this session. There's still quite a bit of extra content that we've made available this week. If you check out the Complete Maths website, go to the Autograph webinar materials page, you'll see that there's some additional files shared there. Hopefully you'll find those really useful. And the how-to guides are there for you to work through these tasks as well. So all the resources for week 1, 2, and 3 are already available. We'll try and get the week 4 documents to you a bit early. We don't want to have them out too early, but we want to make sure that you can use these materials and support them through. Hopefully you found the pace of this session really useful, and you've been able to follow along with the tasks.
Perhaps I'll just show a couple of things. The next topic was going to be looking at velocity and velocity against time, and that the area under a velocity time graph is distance, something that's quite hard to prove without calculus. But it's lovely to be able to create a shape like this and measure its area. We're also going to look at iteration, which bizarrely is a topic in the GCSE. You're not quite sure why, but it is. But it's lovely to be able to move around and zoom in, of course, on what's going on.
And just show them the nice pattern file as well there before I just quickly remind them where they can find these resources again, Doug.
Oh, it's here, sorry. Yep. Oh, yes, well, we've got these two patterns. There's a famous one that comes up every time it's Valentine's graph, but there's so much teaching there. You know, mod x is a function they're supposed to know something about, and the equation of a circle is definitely something they should know about. And if you add those two bits together, you get a lovely heart. And then if you animate it, of course, it bounces. Just lovely.
Excellent, Doug. Well, I'm just going to steal the screen back and say once again, thank you all for coming to the Autograph Week 3 webinar session. On the Salle website, www.completemaths.com, you'll see in the top toolbar there is the Autograph webinar materials. You'll see the Week 1, Week 2 and Week 3 resources, as well as the Autograph files are all available there. We'd like to thank you for attending this session and look forward to seeing most of you for week 4 next week when we are looking at data and statistics. So thank you once again, and we look forward to seeing you next time.